Today I'll be reassessing on Standard 6 from the unit Changing Motion, Particle Motion. This unit is concerned with kinematic equations. Kinematic equations are equations used to describe the motion of objects. Now, some primary quantities associated with changing motion, or the motion that kinematic equations solve for, is position, velocity, acceleration, and time. Kinematic equations can predict these parameters used to describe motion. Now, the three kinematic equations that we used in class are position equals 1/2 times acceleration times time squared plus initial velocity times time plus initial position. Final velocity equals acceleration times time plus initial velocity. Final velocity squared equals 2ax plus initial velocity squared. Now, for an example problem. Okay. A car starts from rest and accelerates uniformly at a rate of 4.9 meters per second squared. What is the car's final velocity after it has traveled 200 meters? Now, the acceleration makes it obvious that we need to use one of the kinematic equations, as kinematic equations solve for changing motion, or acceleration. Now, the initial velocity is 0, which we can tell because the car begins from rest. We don't know the final velocity. The position is 200 meters. The acceleration is 4.9 meters per second squared. We're not given time. Now, we can utilize the kinematic equation final velocity squared equals initial velocity squared plus 2 times acceleration times position. I've chosen this equation because kinematic equations involve 4 variables. To solve, we must have at least 3 of these variables. Now, since we don't have time, I can't use the equation. I can't use the top equation or the middle equation. Now, to solve, we must substitute for the values. Final velocity squared, which is what we're solving for, equals 0 squared, since the initial velocity is 0 meters per second, plus 2 times acceleration, which is 4.9 meters per second, times 200 meters. Now, this will give us a final velocity squared equals 1,960 meters squared divided by seconds squared. So, since we multiplied meters and meters, that gave us meters squared. So, we need to take the square root of final velocity, and therefore take the square root of 1,960 to give us velocity. So we need to get rid of this 2. So after we've done that, we get a final velocity of 44.3 meters per second. That concludes my reassessment.